The swag bag or whatever.
The swag bag came. Which ones? Sometimes it's hard to like parts of my golf. Where we live. That's not very nice either, honestly. I sometimes go have a little more time. I'll run out. And it's like in your arms and like
Oh yeah. I think we're good. Yeah. So you're gonna all right? Cool. Maybe like week 9 we'll totally have this. All right, y'all, grab a seat. Let's get started. Because we get a break in the middle of the class, and like we're going to try to end a little early so that we can get. I want to introduce Tracy Teal, who's the director for data carpentry and software like carpentries now. They've joined and merged. So anyway, I would love you all to have her introduce herself and say a little bit about data carpentry, which is what we are using. All our lessons are largely built from data carpentry material. And Mike and I and Taylor are data carpentry instructors, which I highly recommend. If you are into this down the road, you should do it. It's amazing. It makes you a better teacher, not just in this sort of stuff, but just generally, I think. So anyway, take it away. Yeah.
Hi, thanks Ryan and Michael for having me. So as I said, I'm the executive director of the Carpentries. And what that is it's a organization that teaches computational skills, so software development and data skills. And the way that we do that is we're a nonprofit, and we train teachers to teach, and we develop curriculum. And it's all open source, and it's all volunteer. And so it's a way of sort of scaling this kind of training. And so I'm really excited to be here, and thanks for letting me hang out, because what Ryan and Michael are doing is they're taking this model where we usually do 2-day workshops, and they're doing it in this quarter-long context. So this is, I think, probably the second course that has the same idea of materials that are, you can see like all the things are online, right? So if you go teach somewhere else, you have all these materials that you can teach from. Other people are using the materials that they're developing and teaching them in other courses. So being in this classroom, you're actually a part of a global project of training people in data skills. And why is this important? So I think you guys are from a lot of different domains here, right? So I'm sure we have ecologists. I see some ecologist stickers. We have social scientists.
Mostly all ecology.
Mostly all ecology. Okay.
Yeah.
But oh right, it is an ecology course.
Yeah,
it's a really broad. So I'm a microbial ecologist by training. So really the same kind of stuff with macro in micro realms. But it's really important why it's like great to have this course here, because it's really important that as we are generating all of this data, right, there's like these amazing global data sets, there's the ability for you yourself to collect more project in the field, that as we're generating all of this data, each one of you has a question that's important to you that's different from the person next to you. And so by you having these skills and this ability to use this data, you're going to be able to answer the questions that are important to you and contribute to science and society. And that's true in ecology, right? But that's also true in social science or physics or whatever it is. And so we need more people with the skills and perspectives to work with data to answer more types of questions, right? There's kind of a thing in data science right now where there's sort of like one person who looks like a data scientist, right? And so we need to broaden the pool of people that have these skills so that we can answer questions that are important to a lot of different people. So it's sort of this idea of democratizing data skills. And it's pretty rare to see this kind of course actually still in a university. So it's super awesome that, Ryan and Michael have delivered it. And, they want to think about sustaining this course. They're graduate students. They're going to graduate. And so they hope and plan, and it usually works out that way, It's always N+1 is time to graduation until it's N+1 month. So, ways to sustain this is that, like Ryan was saying, is to become instructors. So it seems like maybe you're just learning this. You say, oh, maybe I'm not thinking about teaching this. But some of the best instructors are people who have learned things recently because they understand what was hard for you, what was a concept that was harder to understand. So you understand better the misconceptions. And you're passionate about it because you see how awesome it is and the kind of cool stuff that you can do. So that's how I came to doing data carpentry, is that I struggled through learning a lot of these things on my own. And I saw how cool it was. And I was like, I don't want other people to have the same, go through the same process of struggling to find where even to look. And I want to share my enthusiasm for these things because it's so awesome, and you get the cool plots, and you can answer questions that you couldn't before. And so I think that energy carries into being an instructor, being a helper, just talking to your lab mates, and using this stuff in your paper and doing something cool and new, or even just knowing that it's there. So even if you don't use it in your paper, like, you know, it's there, it's in your tool chest, and you can use it later on. So as this course hasn't been delivered that many places other than the University of Florida, but data carpentry workshops we've actually now had on 7 continents, and you guys know Taylor. So Antarctica, we just, someone in Taylor's lab just taught a workshop in Antarctica. So data carpentry and software carpentry workshops have been taught on all 7 continents. And actually in Africa is one of our biggest growing regions because it's an ability for them to grow local capacity for training. They're not like bringing in instructors. They're having people in their community as instructors. They're training people to teach. So it's spreading these skills in areas that often are a little bit harder to reach because we're all about building local communities and having people teach each other. So whether you like it or not, you guys are a part of that. And I just love being here. So thanks for letting me hang out. And I guess I will help answer questions and like tell you the wrong thing in R and then confuse everybody. That's my job now. So
highly doubt.
Anyway.
Thank you.
Thanks.
Awesome. All right. So let's talk about what we're going to talk about. So everybody hopefully at this point is familiar with the pieces that you should have open. Again, we've linked on the lectures tab. Make sure you're on week 5. And the live code is here. Week 5 and nothing in there yet. The screencast is going now. Hopefully, we'll monitor that. So far, so good. And then the Google Doc is linked there, okay? So there's the main pieces that we would like you to have open, as usual. So the idea for this week is we're gonna quickly talk about the homework assignment, week 4, the sort of dplyr experiment. And then we're gonna finish up the dplyr lesson that we worked on last week so that we're gonna write something out to CSV. And then Mike is going to take over, and super exciting. Now we get to get into ggplot and really, pretty much after today, you will have all the main components of the tool sets that we want you to learn. We're going to practice those then for the remainder of the quarter and introduce a lot more complexity and things that you can do. But the really cool thing is that basically is you're at that point going to have largely, minus the modeling part, which again, we're not experts enough, so we're not really going to go into that very much at all, but you're gonna have the main pieces. This sort of split, apply, combine concept that we mentioned last week. This graphic is really great. This is from, well, in many places, but Hadley Wickham has a paper that sort of first introduced this. And it's largely this process is what you follow and what we should sort of, if you're thinking about simplifying this is what you want to do. So import your data, clean it up, so you type it. You need to transform it, long or wide, or whatever you need to do. Visualize it, take a look at what you have, maybe do a model, and then you need to sort of do this loop a few times, and then communicate that. And we're going to talk communication. We'll introduce R Markdown and how to write nice little reports and stuff in R next weekish or somewhere in there. Anyway, soonish. So you will have all those pieces, right? And the cool thing is once you have those, you can practice them or use them as much or as little as you need, but you have sort of an entire pipeline that you can work through any problem. And what, like Tracy was saying, that's like not just ecology, but social science, engineering, anything, any data that you get, you can walk through the same process. These tools are agnostic in that sense, which is really great. So, okay, let's recap week 4. So we've sort of covered filter, select, group by, we really just kind of got into and summarize. And so let's go to our, where am I on my screen? There we go. I'm gonna go over here to my RStudio. Actually, before I do this, I also want to reiterate one thing, because when I was looking through the GitHub repositories, so I'm going to go to our GGEUCD GitHub. One thing that and more people have probably added things since I checked this morning at about 8, but there were only about 13 or 14 issues filed on each other's repositories, or 4 on Mike's repository, which is fine. So I really, really, really want you to do this and not feel any reticence about, creating or filing an issue on someone else's repo or asking a question in our discussion repository here. Just because it's called an issue, it doesn't have to be that. So I really, if at the end of this class, everybody has filed an issue, maybe just one, I'll be still pretty happy about that, okay? So just get in the habit, all right? Even if you didn't have anything and you were so kind of confused about the assignment, you can still go take a look at somebody's code, make a comment. That dialogue is really important, and feeling comfortable making that dialogue is important. So for example, let's look at Mike's. Let's look at mine, and we'll file an issue. Actually, I don't know if I can file an issue. I probably can on my own thing, but let's go to Mike's. Yes, let's do that. Why not? Okay, so I have 0 issues on this repository, and I did put a script in here, and I did something that we're going to talk about. I'm going to use it as an example later, where I actually wrote it in Markdown. And so when you click on it, instead of just the code, it actually renders it in this nice sort of format on GitHub, which is cool. And then you can actually see plots. Okay, so let's go ahead, and that's all well and good. Let's file an issue. Nothing here. I go to New Issue. Click. Here's the 2 things that you should always sort of think about doing, particularly in this class. It will make it easier. Your title should be informative. What are you talking about? So in this case, I'm filing an issue on my week 4 assignment, and I'm going to say, how did you do that? Okay. Now, you could just leave it at that, but typically you might want to write some more detail that is useful for somebody to know, or a compliment or constructive criticism, whatever it is. In this case, let's say, nice plots, but how did you make them look like that? Okay? Here's the other part that a few of you have started to use, but I would like you all to get in the habit. Whenever you file something, an issue on somebody's repository, for the most part, they will get an email, like my settings, I get an email saying somebody filed an issue, right? Sometimes your settings might not have that dialed in that way. What you can do is add to the front of this a name. So it could be my name in this case. So my username is Brian Peak. So if I do that, that's basically tagging that symbol in the front. And that means I will definitely get a message saying like, hey, somebody sent you a note. You'll notice when Mike and I have been sending out the emails or the notes on the ents repository, we usually use @ents. Okay, and that pops up, and if we hit enter there, this means that everybody would see this. You would all get an email because you've been tagged in this. It's kind of like a Facebook hashtag or tagging somebody in a photo, right? It's the same idea. So those 2 things are really, really helpful, and I highly recommend it, especially if you file an issue. If you tag Taylor or Mike or I, we're probably going to get back to you more rapidly. I try to check, but I don't always check every day. So if you do that, then I guarantee I'll get back to you more quickly. Okay? All right, so then I just submit new issue, and there we go. And I will get a little email letting me know that that's something that I should take a look at. One other thing let's do, I'd like everybody to go to the Teams. Actually, here, we'll go from the Google Docs, because I think we already have a link in here. Ents discussion, yes. So let's go to this link. Open link. Okay, so this automatically takes us right to our discussion board, right? That you're all a part of. Down here, the little button, all of you see a button on the left. Make sure that you have watch on here. This is where you can turn off your notifications. So if you're part of something, you're getting a ton of notifications and you don't want them, you can turn this off to not watching. And that means you'll be notified when you have mentioned, like I was talking when you're tagged, but you won't get anything else. If you're watching, anything that shows up there, you should get an email. So I think this might have been why some folks didn't get a notification, an email. So make sure for this, let's make sure we all have watching on there. Okay. Yes.
Some of my emails from the group, my spam.
Spam, yeah. There's always that too, yes. So double check your spam that it's not. Really? Huh.
Yeah.
That's interesting.
Yeah, but it's not that great.
Yeah.
But I haven't checked in spam. I just like get some every
Yeah.
once in a while, but then this one that I just see, I'm like, well, I didn't get emailed. I didn't get emailed
Okay.
that one, but I've always been on.
Okay. Yeah, it might be just a Google the way it's filtering something. So, so anyway, that's one other thing. Make sure that you can turn that on and off depending on what you're participating in, and that's repository specific. So you can watch a single repository. Like there's a few folks that do some really cool coding and whatever they add stuff. I want to know about it in their repository, so I watch their repository. And then if any updates happen, like Richard McCalris, rethinking repositories is a good example, right? Like anytime he posts an update or something happens, like I get a little note and I can go see if it's something interesting. For others, you may be able to just constant stream of stuff that you'd rather it go to your junk, so just turn it off, unwatch it. All right, any questions on that? On the filing issues? All right. Then I highly encourage you all to file some issues in this coming week. And they can be simple questions on the discussion repository. They can be on somebody's code, whatever you want to do. Okay, so let's jump back into our homework assignment from last week. And so I'm going to use my repository here. Can everybody see? Can you turn the lights down? I feel like it's hard to see. Let me make this bigger. How's that? Thank you. That's much better. Great. Okay, so I have my header. I used this. Remember that little TS tab bit that was kind of a fun thing? If you hit TS and tab, you can paste in the current date as a section. So I use that at the beginning of mine. Let's load our library, and then we need to load our code. And then take a look at that code using glimpse, which is similar to structure, str, right? Let's add a comment in there. str. I'll copy this over to the live code in a second. And Mike has this in his repository too. So the objective was to reorder everything, right? And so we had all these lines of code, and we wanted you to reorder them in a way that you end up with this outcome. So the idea was to generate $1 per day for GDP. And in order to do that, we always want to start typically with our what we're assigning to, and then the data. So we're piping our data into the rest of the steps. And that data is what all this ends up coming back to is this name. So we're going to assign this to our environment. Mutate, what does mutate do? New column, right. And so we're going to create this new column. And here's our function. We're dividing the GDP per capita by 365. So we have a daily GDP per capita. And then we're going to filter that to less than 1, daily GDP less than 1. I'm not sure why I did that. Did you all do that? Great, okay. And then select. So again, you could stop here. You could the way this type works is I'm just sort of adding these things, but you could easily break these up into different chunks and just type maybe one thing and then stop. But then you would have to restart with this again and either assign it to a name and start with data again. So this is why the type is kind of nice. It's like this is one discrete sort of process where we're ending up with this one data set at the end that's been clean to what we want. Select country, year, and GDP per capita. And then we're going to arrange. So I use this little DESC, which is descending. So you can change the order that you arrange something by, which is actually really handy if you want to sort your data in tidyr or in dplyr. You can use the arrange. And if let's run this and see what we get. And so if I take our limited screen space here and look at this, so right now it is sorted by year. So starting with the highest year and going down, right? or the most recent year and going into the past. But if I took this DESC out, it's going to do just the opposite, right? So now we have the oldest to the most recent. So the cool thing about arrange is you can add a few columns in there, so you can sort of arrange by multiple things. It's a really handy little trick if you want to look at your data or see the sort of certain pieces of it. Okay, so any questions on just reordering? Yeah.
Does it matter if you select before you take it, not selecting?
Would it matter? Well, so what are we selecting? We would have GDP per cap and country and year. So if you move that, let's try it. Then what do you get? Same thing, right? Is it 16 by 3 and 16 by 4? Right. Oh, okay. So if we change this up again, so right now we have 4 columns. Oh, sorry, it's off the screen because this. Open that up a little bit. Let me look at this again. So now we have the daily GDP per cap and country and year. The reason that is, if we had selected here, because we had to use GDP per cap in this. Okay, so if we select this, we just have those 3 columns, right? And then if we need to, we're adding 1 more column, so we have 4 columns at that point, right? I moved that, so that's what we did. And the other outcome, if I put it down here, do we have 3 columns? So does everybody see the difference? So there we go. There's 3 columns. So just the result ultimately is the same, but you're depending on when you're doing that, it's carrying that sort of data set forward. That's where the pipes do matter, right? But ultimately, like that is sort of you get the same result that you need. You're just adding an additional column. Okay. Any other quick questions on that? Cool. All right. I'm going to. Should we show this, or should we jump into the dplyr, the rest of the topology?
Up to you.
Up to you. All right, I'll show this. I'm not going to show the ggplot, but let's show the how we got the next little bit, because actually it's good. We're going to basically do this in the ecology stuff. So one thing, the questions were calculate total GDP of each country in each year in a new column, and then calculate the variance of all countries' GDPs in each year, and then plot if you wanted to. So print, have we covered print? Print is another one, and you can print, however many rows you prefer, n equals 30 here. And then I'm using this as a way, let me break this up into the chunks so you can see what's happening. I often, when I want to see what is going to happen to my data if I group something, like if you're not sure, you're like, well, I think that's the group by I want. And before you assign that to a new object, you can just pipe it out and look at it, right? That's the cool thing about this. It's really fast. Play around with it, figure out what it is you want, or that it's sort of the right data set that you've sliced and diced. And then when you're satisfied, then you can assign it to your environment. So first, I'm just going to start with the data. I'm going to pipe that to group by country and year. Because what I wanted to know in my sleep-deprived mind when I emailed Mike, like, I don't understand this, was, well, wait a minute, how many countries have a single year? Like, they're all a single observation, right? There were no countries that had multiple observations across years. Does that make sense? I'll show you what I mean. So I'm using group by country and year, and then I'm tallying that. So that's just going to summarize how many country and year counts do we get, and then arrange that in descending order. And so what I ended up with is this column N over here, and they're all one, every single one. So there's one value per country per year. There are no sort of, you can imagine like maybe Afghanistan had multiple records for 1952 or something in your data set, and you wanted to know that. Because that would matter if you were, because then you have to think about, are you taking the mean for that single year, or the sum, or the max, or the min, right? Does everybody understand what happened there? Okay. So anyway, take a look at your data and see if that's what you want to happen. So at that point, I was satisfied. I'm like, all right, now I know that if I'm going to add a new column, and we're going to do population times GDP per capita to get our total per year. That's going to be the total for that year for country. There are no multiple records. So that's what we do. So then we assign this to a new object because it's going to add a new column, and I didn't want to overwrite my original data set. So I do that, and then let's take a look at that. And again, we can't entirely see that because it's not much real estate, but okay, there we go. So I made a new column called year GDP, and the C scientific notation isn't as easy to read, but it does truncate it, which is nice. And there you go. So we have a new column that's our annual GDP for that country, for that year. Cool. And if you were to add variance, you would do a similar step where you would add GDP. So we would summarize by year. In this case, I did this. So I'm going to take my GDP, group by year, and then summarize. I'm going to make a new column. And remember, summarize, what's the difference between summarize and mutate? Anybody?
I really don't know what summarize means.
Okay,
Doesn't summarize take whatever you've grouped it by and then take whatever, you could say mean or variance or whatever max, min, right? Groups by whatever your previous thing is.
True, but I think the thing that I think you should definitely think about is that mutate is going to add a new column to your existing data frame, right? This one here, the GDP, got added to our existing data frame. But summarize is going to make an entirely new data frame based on what you're grouping by, like Ross was saying. Okay, so summarize is really neat, but you're getting something entirely different back, something new, based on what you're grouping by and based on whatever function or thing you're creating here. So it's similar to mutate in that you're creating a new column. You're creating a new column based on these grouping variables, and it's an entirely new data frame. Okay. Down the road, we'll show you how you can join those things. You can go back to this original and join. You can create something new and join it back to this based on a column. But for now, I think the main thing summarize is to sort of spit out a new data frame. So if we think about what's happening here, we're grouping by from this data set right here. All these years, how many countries? There's lots of countries. Every country has lots of years, right? Every year. There are probably, what, 30, I don't know how many countries there are, but there's a bunch of countries. So for 1952, if you're grouping by 1952, you should end up with 30, if there are 30 countries, 30 records, right? So that's how that grouping is working. So when we group by year, where am I? Down 41. Up higher, there we go. So if I group by, not down here, 51, yeah. Group by year, and then summarize, and I'm calculating the variance of this. What I'm going to get is the variance of all these records for 1952. That make sense? No, feel free. If it doesn't make sense, we can, because we're going to do a lot more of this. So I want to make sure that if you have questions, let me know. It might be a little hard to get, but the more we do it, hopefully it'll help. I think the more of these things you do, where you start grouping things and summarizing, hopefully it will make a little more sense. All right. Yes, that's what you would get if we do every year by that. Yeah.
How would you do it if you weren't using a pipe?
Confusing? Well, yeah. So we don't have to use the pipe.
Yeah, can we see something with just summarize? Did we do that last time?
So
This would be new to me when I saw it.
I think we did one. Did we do a summarize at the end of class last?
Yeah, it was at the beginning.
The very end, yeah, because that's right. We summarized by male, female. Why don't we switch over? Because I want to make sure we get into ggplot today. Why don't we switch over to the ecology data set, and we will definitely show summarize a little bit more. Because it's a good question, and I'm not sure the best way. Essentially, to use summarize, you sort of have to pipe into. I mean, you have to do this group by beforehand, right? And then to do into summarize. I'm not sure how you would do it without a pipe. And so yeah. Okay. All right, so let's switch gears one more time. And we're gonna go into if you haven't created a new script for this week, feel free. But I'm gonna now be in the live code for week 5. Flyer, and we're gonna summarize and write to CSV today. And then Mike's gonna use that in the next bit. CBS, CSV. Okay. So last week, let me look at our week 4 code. Last week we had, where do we end up? We ended up, yeah, here's our group by and our summarize. So we had sort of played around with how to filter out the NAs and then summarize by sex and species, 2 different things we were summarizing here, and then summarizing by mean weight. So for every sex and species, we were taking the mean weights. Today, what we want to do is basically get you to the point where we are going to export our data. And so what I'd like everybody to do is, let's copy this code over, which I know copying over is not ideal, but we're going to do it. So I'm going to copy our library and surveys because we want to bring that forward from last week. Okay, so we need to read in our library, and we want to bring our surveys in. Okay. Okay. Then we're going to sort of take this data. I'm going to add a section break here. We want to remove NAs from data. So to do that, let's call this surveys complete. It's going to be our complete data set that we're going to end up using. And we're going to take surveys, and I'm going to pipe that into a filter, right? If we want to get rid of the NAs. So filter, how do we get rid of NAs for weight? Let's say weight is we know there's NAs in there. How do we get rid of those? Was there a function that we used before to find the NAs? What was the function? Is.NA. Is.NA, yeah. And how, so is.NA, what is that? It's just logical, like true and false, right? So how would we say we don't want the NAs if we're using is? Yeah. Exactly. Nice word. Is.NA, and then weight. Okay, well, turns out there's more NAs in here, and we want to get rid of those as well. So we're going to just keep filtering. I'm using the comma here, but remember, comma means and. So it's doing and these other things. So hindfoot length and is.NA is sex, I think is the other one. Okay, great. All right. So let's really quickly look at how big is our data set in our environment. 34786 by 13. And if we send this out, we have now dropped about, what is that? 4,000 records-ish, right? Okay, so that's great. But the other thing is, remember this has like a ton of species in it. And say there's like a bunch of really rare species and we're not as interested in, there's like many species that maybe you only see once or twice. And because we're ecologists, we're not totally focused on rare species all the time, but maybe some of the common species are important too. we're going to go ahead and filter the, basically create a new data frame where we look for just the most common species. And so to do that, how might we want to step through that? Remember, this is going to use filter and then a command that we may not have seen yet. No, we use tally. So if we want to get the number of records for each species, how might we do that? So let me add a note over here. So let's filter to most common species. So let's say species counts. Let's make a new data frame called species counts. I'm gonna move this up a little so you can see it. Okay. Now, what do we want to use? We want to use surveys complete, our new data set. Yeah. Yes. Oh. Is that good? Okay. Is the screen a little blurry? Is it just me or? Okay, sweet. When we came in, it was like over here on the wall somewhere. So I don't know, like an earthquake or I'm not sure what happened, but I apologize. We'll maybe fix that at the break. Survey's complete. Okay, and then what do we want to do? We're going to count the number of species. Let's use species ID. So maybe group by species ID would be good to do because we need to get a count, and that's our grouping value. Okay. Now tally. This is where tally is really handy. Tally gives us that column. It just makes a new column called n, right? That is the number of that group, the total number. And if we want to then pipe that to filter to get the most common, let's filter n, which is that new column that we just created in tally, greater than or equal to 50. So we want more than 50 observations per species ID. Okay, now if we look over here, let's look at this species counts. We can see now we've got a nice data set. There's only 14 species that actually match that criteria. Now, if we change that up, we can play around with the n is greater than and equals to see if we get, until we get the right number. But for now, let's use the greater than or equal to 50. Okay, so then let's go back and let's figure out how we can use this table, species ID and n. Let's figure out how we can use that to filter the most common species from our whole data set.
Question.
Yes.
With tallies, like there's nothing in the parentheses, so does it know that you want to, is this supposed to use species ID in the line right before? So whatever was right before it, it'll.
Right. So I put this here so you know it's a function. You don't necessarily need the parentheses, but this is that's a really good thing. So the pipe is doing what? It's sending whatever's on this line to the next line. The outcome of this goes to the next line. What that looks like to the computer is its dplyr is filling this box for us. It knows that is what's up there. So technically, I don't even need that. I could take that parentheses off.
So you need to use the group by before you think tally? Before
Yeah, because it needs to know what to tally, right? And so let me show you this. Parentheses is the same actually. If I use a period here, it gives me the same thing. Period, it means like the data, right? It's a shorthand for the data. So I can do that, or I can do nothing. All three of those things do the same thing. But I do want that period is important because down the road it's like a placeholder so that you can put data equals period, and that's sort of like use whatever was up here. Okay? Yeah.
Is tally like a type specific function, or is it?
Yes. It's a dplyr. It builds on other count and other things that are in base R, but yeah. Yes, Taylor. Just the tally?
No, up until the point, so highlighting service. Yeah, so that,
Or not?
so everything that's on line 23 and 4, running that.
Right.
Yeah, oh, I see what you're doing.
Yeah. If we just do this bit.
See what happens. Like,
So this gives us the same exact thing, right? So it's grouped by, but it hasn't done anything. It just gives us the same data set back. Okay. So it basically group by is kind of like an invisible thing. It's just the dplyr is sort of looking at the table and saying, oh, okay, I'm going to use this as a grouping value if you want to do something with it. But it doesn't group by itself, doesn't actually return anything unless you do summarize, tally, or mutate, or something like that.
So it didn't even reorder it?
I don't think so. No, it just gives you the data set back. Yeah, the exact same thing. It's a good question.
If it's not doing, I'm so confused as to
How it works.
how it would change something after that if it doesn't do the end of it. So.
It is doing something. It's behind the scenes, but it's not. We're not going to see that output when we print this table out. It's basically identifying that column. It's sort of with an attribute, sort of links to that column, saying like, "Hey, if you want to do something, I know that this is the column that you want to rearrange things by, and then we'll keep them." Yeah.
So tally similar to summarize creates a completely new data frame, right?
Yes. Yeah. And that's it. So the way, think about this group by. Whenever you do something with group by, it's going to keep those columns. Whatever column you group by, it's going to bring those forward, and only those forward. So when we do species ID and tally creates a new column called N. If I had species ID and like 3 other columns here, it would do an N for all those grouping values. It would bring all those columns forward. But those are the only things that are going to come forward. Does that make sense? Mm-hmm. Or come, when you spit it out. Good questions.
If you did that right, would you say your filter and it's greater than 50, but all of the ends have to be greater than 50?
Yep.
Okay.
Yeah.
Would there be like you want species ID to be less than or greater than 50, but you want your other column to be less than? Here,
let's just for an example, let's add another grouping variable. Okay. So let's say group by species ID and let's do sex. This is now going to split out male and female for everything, group by species ID and sex, and it's going to give us a tally of that. And let's take a look at that. So now, see, it brings this forward. Now it's being an N, but again, it has to be greater than 50 for that, unless, no, yeah, it should work. Yeah, so everything's greater than 50 in this, greater than or equal than 50. Yeah, and you see how it brought that column forward in addition. So however many columns you put in group by, those are going to come with. Okay. Any other questions on that? It's really, they're all, this is, I know it's a little sort of, it's a very different way to think about it initially. I think the more you do this, hopefully the easier it will be. So let's go ahead and now take that and use it. So we want to use that table, species counts. Just make sure I run the updated version. And we're going to use that to filter our surveys complete. Okay. So surveys complete. I'm going to write over that same thing. So notice that I'm changing this data frame. I'm doing something to it, but I'm keeping the same name, which isn't necessarily the best idea, but we're going to give it a shot. So filter, species ID. Now, do folks remember the % in %? So that's saying for look in something and match it with that column. Move that up a bit. So species in, species counts. This is the part that might be a little tricky. Do you remember how to access a single column in a data frame? $? Right, so see, is when I type $, suddenly it brought up everything that's potentially available for me to use. And in this case, I want species ID. So what is happening here? So we're doing species ID in this list of species IDs. So it's basically looking in this table at that column specifically and going to match it to this column. So I'm filtering to only those species. Got it? Any questions? All right. So let's go ahead and let's take a quick look at our dimensions of our object first before we run this. And so remember, we have 30,676. Okay, so we went from not a big change, 30,000 to 463. So okay, just another minute or two, and then we'll be hopefully at our break and ready to go into Gpot. Okay. So green stickies up if you have a surveys complete that has 30,463 rows. Whoop, what just happened? Okay, now we're going to write this out. This is the cool part, and this is where we can break CSV. Okay, we've talked a little bit about spreadsheets and why we would like to use CSVs versus spreadsheets. Part of the tidyverse, they have a package called readr, which is what we use to read in the CSV. You can use the same thing to write out a CSV. So in this case, we're going to use write_CSV. And at this point, does everybody, if you go look in your files before we do this, does everybody have a data output folder or just a data folder? Just data. So why don't we make a new folder? Because again, remember that what's in the data folder? Raw data, right? Like, so now we've done some cleaning and we want that to be in a different place. So let's make a data output, all lowercase. Do I use a space? Yes, that's the best. That makes me happy. Okay, data output. Great, so now I have this new folder. So I clicked on new folder, typed in data output. Now I've got a folder in there with nothing in it. So now let's write our data. So write_CSV. And I'm going to hit tab once I have my little parentheses to see what it needs. All right, it says X. I need a data frame to write to disk. Well, let's use surveys complete, which we just made, comma, tab, path. Okay, well, what is my path? Here's the cool thing about projects. We're in our project. So the only thing that we need to find is data output. You don't need anything else before that because we're in your project folder. So I'm going to type data output. Now, if you hit tab, most folks, hopefully, you should see a folder that shows up, which means you're in the right place. It sees that. If I hit enter, it automatically puts that in my path. That's a good double check to make sure that whatever you're trying to save exists, right? Tab is really a lifesaver in that it's trying to make sure that you're in the place you think you are. And then surveys complete. I want to call it exactly what it is, .csv. I have to add that. And I'm going to send that. And then there you go. Now you have a data set, CSV, nice and clean, ready to go. Any questions? Yeah.
I have a question about putting sections of code in your code.
Sections of code in your code.
Yeah, like, can you put sections within sections?
So we will get, yes, that's more an R markup. You can definitely do chunks of code and separate them with text or whatever you want. But in a script, the best option really is this section break, these section headers where I do Command or Control Shift R. And then the nice thing is that shows up as in my little outline over here. You can find those different pieces, or down on the bottom here, it shows up as well. Okay, so that's in a .r file. That's your best bet. in a .rmd, our markdown file, we'll talk about some other options. Yeah.
So you're saying that in a .r file, there's only one level to that. You can't.
I don't think you can do. I guess if you write a function, I think it shows up as a separate. But yeah, I think there's. Unless somebody know a fancy trick to do that. No. Yeah. So limiting, I know. Yeah. Okay, awesome. Thank you all. Let's take a break, like 5-minute break, and then we're gonna jump into ggplot. Okay.
Okay, and here is the ggplot syntax. Let's not, we'll get right to it. So to create a ggplot, we call the ggplot function an open parenthesis. Key note here, the package is called ggplot2, the function is called ggplot, and that's it. So ggplot, and yes?
If we haven't coded our environment into this, is this going to declare it for the surveys to be, because it comes up with that, pass with all these specification thing.
Right, so that is standard behavior when you do the read CSV. It tells you what, was this column a string, was this column a numeric, the different kind of types. The short answer is no, you'll be fine, whether or not you started fresh or just continued on. Essentially what we did when Ryan left off was we wrote that data frame to a new file, and now we're reading it back in even though it was already part of our environment. So we sort of overwritten the surveys underscore complete object with the result of the surveys underscore complete thing that we just finished creating.
That is good practice.
Yes, and I hesitate because how are you clearing the environment?
Pressing a little blue.
Okay, and I don't know how thoroughly that clears the environment. So if you need to clear the environment and like let somebody else run your code and see if it works properly, close out of RStudio and open it back up. That's the certain way of clearing everything and making sure there's nothing left sort of lingering.
So ggplot2 is in tidyverse. So
Yes. Yeah. So ggplot2, the package, has already been loaded when we did library tidyverse. Exactly. Okay. So ggplot2 is part of the tidyverse. So what is the first argument that's going to go to this function? The data, right. Okay. So we're going to pass in surveys underscore complete. Oh, and you know what? I'll be explicit here. I'm going to name my arguments. I'm going to explicitly say that the data are surveys underscore complete. And I think that even will run. And we get this sort of blank canvas here, right? And that sort of hints at how we are going to create these ggplots. We're doing it layer by layer. So we set up the canvas, and then we add these different layers as we want to add different components to our plot. So let me write that explicitly. This will create the canvas. First argument in tidyverse functions is the data. Okay, but really, I want to be able to take data and visualize it, right? So we do that by adding geometries to our plot data. So I'm copying the same line as before. I'm just showing a more complete way of doing it. Oh, thank you. Oh, that's not what the R code is. Surveys. Okay. And sort of the key, and when I learned how to use ggplot, this is sort of what blew my mind. When we have data and we want to translate that data to a visual feature on the plot, we use what's called an aesthetic. The aesthetic function is lowercase aes, and that specifies that, okay, everything within this function is actual data that we want to map. We call it mapping to a visual feature on the plot. And so we can think of a few different ways of visualizing data. Maybe we want species with different shapes, or represented by plotting characters with different shapes or different colors, or that sort of thing. But the most basic visual features that we want to think about with the ggplot are literally the x position and the y position, right? So we do that intuitively maybe when we make a scatter plot, but we're going to be explicit about it here. So in our ggplot call, the next argument is going to be the mapping aesthetic. So we use the AES function, AES open parenthesis, and we're going to say that the x position is the weight of our surveys, complete data frame, and the y position, oops, y equals the hind foot length, let's say. So this is going to, this AES function is going to look inside the survey's complete data that we have for the weight column, and it's going to translate the different values within weight to the x position on the plot, on the scatter plot. And then it's going to take a look at the hind foot length column in the survey's complete data frame, and it's going to translate those numbers to the y positions on the plot, right? So when we are translating data to visual features on a plot, we use the AES function. Now the way that we add layers, oh, this is just conveniently slightly too short. Okay. So now when we add layers, we use the plot function call creates canvas, and then
The plus outside the last one. Here is it
No,
inside?
it should be
Inside the whole.
that parenthesis.
this one here.
Yeah.
Yeah, no, the plus goes outside of it, right? So everything's self-contained, and then we do a plus to say now we're going to add a whole other component to the plot. Yeah, good question. So plus, and the way that we add these features are with geoms, which is short for geometry. So geom underscore point, open and close parenthesis. That's going to take all of this information that we've used to create the ggplot, and it's going to add point geometries. I'm getting that flag. Well, let's run it. Let's see what happens. Just like that, and it shows up down here. My plot pane is down here with the files and the help, that sort of thing. So it should show up in one of those 4 panes for you. Yeah.
One quick thing to note that I think throws people sometimes and can be really frustrating to find is that plus, when you're adding a new thing, has to be on the end of the previous line. You can't finish a line and then put a plus at the start of the next one. That won't work. And that can be extremely frustrating when you're looking at it and you're like, I don't see what's wrong, all my arguments are right, and then that's the thing that's wrong. So you always, while you're building these up, if you're gonna do a new line, gotta end it with a plus.
Make sure to add the plus sign at the end of a line and not the start of the next line, right? So let me show you what that looks like when it's broken. What Michael's saying is, type it out, ggplot, and that was actually the next thing we were talking about, I think. So survey is complete, AES, x equals weight, y equals hind foot length. Oops. So if I do a plus sign here and geom underscore points, that will break. Is that the idea? Oh, except that I've also had this be a so equals. So that should also break.
Won't include the next line.
Won't include the next line. Got it. That's a better way, more precise way of putting it. Right. So make sure that the plus sign goes at the end of the line. Yeah.
Why plus sign and not like?
Yeah. This trips me up every time. I don't know. And I feel like the way that I think about it and try to keep them straight in my head, well, let me back up. I make a mistake all the time, right? Like instead of a plus sign, I'll put a pipe instead, and you all will see me doing that, and you'll say, hey, Mike, you're doing that again. But so if you think about with the pipe, it is taking a thing on the left-hand side of it and passing it as an argument to the right-hand side of it. And the plus sign in ggplot world is the thing above it is like it's self-contained. Right, and the next thing after the plus sign is also self-contained.
It's just an additional argument, not an argument.
Yeah, right. So the pipe is like passing things as arguments to functions, and the plus sign is building up layers to a plot. So they are fundamentally different, but that's totally a confusing point. Yeah.
So for and, we can only use and inside.
Correct.
Yeah.
So one way to think about this is when you're plotting, think about a plot that or if you were drawing something like painting, right? You put one layer, and then if you wanted to change colors, you would do another layer. And to do that, you would add a color or add a layer. Whereas and the pipe do different things, right? And is a sort of function of it needs to meet and something from something previously, and the pipe is passing something along. So the plus in this way, but it's very confusing, don't get me wrong. The plus in this way is you're adding another layer, another sort of visual piece to the puzzle, right? That's the way I think about it, to at least try to illustrate my mind.
Somebody had a question here. Oh, follow up. Sorry, stand by.
So, plotting, or maybe just GG plotting. In the first brackets, the only things we can put in are data and X, Y. Like you can't ever add aesthetics. You always have to close your bracket and have a add a new layer.
Up in this. Yeah. So the ggplot function call is where you set things up, and you're not actually adding the visual features. You're not actually adding those layers until you use the plus sign, as far as I understand.
So at this point, with this last this code here, why might the plot not actually show up?
So
here?
This is getting to that reason why we put the plus sign at the end of this line, right?
No, sorry. I'm talking about the right one, the correct one, line 54.
Oh, yes, this
one. So I ran that, and like nothing is visualizing over here in this plot thing.
In this world here?
It's not showing up anything. Why might that?
Yeah, we'll see. It might be something idiosyncratic. That should give you the plot that we're looking at. So to be explicit, this will be waiting. This will not put the geometry on the canvas, on the ggplot. Make sense? Okay. One of the cool things too about ggplot is that you can save the ggplot itself as an object. So let's say we're going to call this surveys underscore plot, and we're going to assign that to be, oops, skipped up, our ggplot with surveys underscore complete. Excuse me. Data equals surveys complete. Our aesthetic, the X position is going to be weight. The Y position is going to be hind foot length. So what this will do is it will sort of save this, the result of this ggplot function call, the creation of that canvas, to an object. And then, sorry, let me add a comment here. Save the ggplot pieces as our objects, aka variables. And so, okay, we did that. Now we can use the plus sign just as we saw. Surveys plot plus the geom point. Because we saved this ggplot call as this object surveys underscore plot, now we can still use the plus sign how we might have used it when we wrote everything out and add these additional layers as we see fit.
Why would you do that and not, like, would you have reasons for writing your code one way or another?
Sure. I guess if it were me and I knew that I was going to use this line a whole bunch of times and making different sorts of plots, it might be nice to kind of save it as this object, and then I could make a geometry point on top of that, or I could make a line plot on top of that, or what have you, and sort of keep those separate. So I guess that'd be one way to do it. Another way to think about it is you can actually save the plots themselves, like as PNGs or as as picture files in your computer, and so you can specify, oh, I want to save this object, which contains all of the plot itself, and then you can just refer to that object when you're saving it to your disk. Yeah, good question.
Did you do it this way also if you were trying to decide what plotting you liked the best, but you were always using the same canvas?
Sure. Yeah, exactly. Right. So if I know that the X is always going to be weight and the y is always going to be hind foot length, then yeah, you could say that and then try some different kinds of geometries on top of it. It's reasonable. Any other questions? All right, let's get you all plotting. Oh, you know what? We're going to talk a little bit about overplotting, right? There's a lot of data on this particular plot, and some points are plotted on top of each other. It's sort of hard to see what's going on. So what I want you all to do is install the hexbin package using this line. So when we install packages in R, we can use the install.packages function. And then in quotes, we're going to type the name of that package. And if we have internet connection, run this line here. And then it downloaded it. And remember, we install a package once, but every time we want to use it in any new R session, library, hexbin. Okay, so now we've got this hexbin library loaded. And what I want you to do is take this surveys plot and add a hexbin geometry. So if geom underscore point is how we would add a point geometry, how might we add a hexbin geometry? So think about that. Take a couple minutes and see if you can recreate this plot, but using a hexbin geometry, which we just had access to by installing the hexbin package.
So Mike, would you just like hashtag that install packages in your code so that if you like open up your new code and you just run it, you're not re-downloading it every time? Yeah, that's how I've been doing it, and maybe other people have good suggestions on how to deal with that, but that's how I've been doing it. All right, so
Is it a function in ggplot also?
it is, and here think about. So here I'll give you some starter code. So remember, we're going to take the surveys underscore plot represents that ggplot canvas. And before we added geom underscore point to create this plot. So modify this code to add a hexbin geometry instead of a point geometry. And remember, if you have questions about a particular function, you can Google it. You can use question mark to, for the hexbin package, for instance. Try to find an answer. Go ahead and work with your neighbor. That seems pretty right. Yeah. Read sticky notes up if you've got a hexbin plot. Read sticky notes up if you need an answer.
We're doing it wrong. We're all doing it wrong. We're all in this together, baby. Typed in geom and then I did that.
Yes, thank you. This explicitly.
Yeah, I mean, we can find out. Not just
Hang on, what's that? Sorry.
This is not working.
It's not working. Can you go to
I
your...
mean,
Oh, I have it.
yeah.
It's not, yeah, it's not showing
I mean, I
on.
feel like this, but I'm trying.
Yeah, sorry, where do you want me to go? Do
Um,
you want me to cancel out of this and bring it back?
Sure. Let's try that.
save this. Continue the philosophy of building a plot iteratively. So we're going to start with surveys underscore plots. Oh, and you know what? Let's type this all out so we're being really explicit here. So ggplot, first argument is the data. Data equals s, x equals weight, y equals hind foot length, plus sign, and let's add that geom point. And remember, this is what this looks like, the plot that we had before. Another way that we can deal with this overplotting is by adjusting the transparency of those points. And when I'm changing a visual feature on my plot, but it's not related to the data, I'm not actually translating data to that visual feature, I don't need the AES function call. So if I want to change the transparency, we can use the alpha argument within the geometry. And let's set it to a 10% opacity. So 1 is fully opaque and 0 is fully transparent. And now when I run this pipeline, now these points are coming up a little bit, they're coming up at 10% opacity. So you can see a little bit better where the real density of those points are. And so that's the theme that we're going to see a lot, right? We use the AES function up here when we're saying, okay, I want a visual feature to be related to the data, to be related to the weight column, or to be related to the hind foot length column. But if I want to apply something across the board to the whole plot, regardless of what the data are, I can just specify that argument directly. So let's do that again with add some color to the plot. ggplot data equals surveys completes. Points, alpha equals 0.1, and color equals, let's say, blue. You can pass the name of a color directly in quotes. And we end up with blue points. And here, I hope this this next example will be illustrative of that idea. Let's color the points by species. So we'll say, oops, ggplot data equals surveys complete. PES to say, whoops, we're mapping the weight to the x variable, or to the x position, mapping hind foot length to the y position. Let's add geom points. We'll still keep it every point a little bit more transparent. And I'm gonna, before I finish this, enter it up so everybody can see it. Okay, if I want to color points by species, species is some data within my data frame, right? So if I am mapping those data to a visual feature of the plot, I need to use the AES function, right? AES, and we can use the same kind of argument, color equals, and the, what's the species ID column name? Species, what is it, underscore? Underscore ID. Just like that. Cool, right? So does everybody sort of see how the difference between setting the alpha across the board for all of the points and then setting the color based on data in my data frame? The sort of difference between those? That's a really key difference in the sort of philosophy of ggplotting. Yeah. Yes. Yes.
Yeah, can we try to like add a color for a specific species? Like, so they put in just sort of random colors, but say you wanted things to be, you wanted DN to be bright pink. Like, can we just try that really quick?
We can try really quick. I don't know it really quick, so I'm going to go to our friend Google.
So you can put in a string. You can put in your own color scale. It can be fun.
You have to go in the right order.
It's not the easiest thing in the world, but you just have to minimally budget possible. For sure.
We don't have to do it now then.
Should we stop? I'm fully in here.
Okay, cool. Let's
That's what I would Google. And here's, ggplot2 is also great because there's a big community of users, right? And so there's great cheat sheets and there's great tutorials out there. And so almost anything that you want to do, it's possible to do. It's just a matter of finding the right pieces. So this would be using scales, and that's another thing that you would add as a plus sign.
Okay.
So we can start down that path. Let's see what the next question is, and yeah, maybe I'll leave you to Google that more on your own.
I was just wondering if these commands would be the same between ggplot, or is it a totally different thing?
So no, so ggplot2 is the package that we're using, and that's I think like ggplot is old and deprecated. Hadley Wickham might have written that during his PhD, I think. So ggplot2 is what that's the standard that we use, and ggplot is the name of the function. That's the distinction there. Yes, this is all ggplot2.
So there's no ggplot2 function.
As far as I know, yes.
Okay.
Yeah.
I have a question about self-help with the question mark.
Yeah.
Okay, so when you were telling us to do the hexbin thing,
Uh-huh.
download hexbin, I did question mark hexbin,
Okay.
and like nothing about geom hex comes up. So this happens to me a lot where I know there's some hex thing I want to do.
Yeah.
I do question mark hexbin, and it comes up with this thing that looks just like my ggplot where I can have to put in data and an x and a y, and nowhere in there is geom_hex.
Right.
So how would I get from the
So my approach is I try the question mark thing first, and if that doesn't sort of immediately give me a way forward, I'll go to Google and see if that gives me an immediate way forward. I like do a breadth first analysis, right? Of like trying a few different things and seeing what seems the most promising before diving in deep with one particular way. So at that point, I would have gone to Google.
And typed in like how to put hex.
Yeah, and if you yes, and tagging a ggplot will give you loads of help. Have we talked to you about the Stack Overflow website yet? All right, let me do that. You have a point too. Come on.
One quick thing, so it's because there's actually a function called hexbin. So when you read question mark hexbin, that's a different function.
Right.
A tip is to try 2 question marks as well. What that'll do is it does like a broader search for help pages that match with some hexbin. And what you'll see is that within the hexbin package, there are a bunch of different functions. And then you can look at like specifically which one you think you're looking for.
You can also list all the functions in a package pretty easily.
Oh, how do you do that?
I think you just do like ls parentheses.
Cool. Okay. We can Google specifically how to do that too. That's all. That's good to know. I didn't realize that. Yeah. Okay. Sorry, you said ls and then the like hex bin or something. Oh. Yeah, we'll find out. We'll let you know. Yeah.
Can you say one more time why color equals species has to be within AES?
Yes, and it's super key. So I will write it down too after I say it. So we've got this data frame, right? And if we want to translate data to a visual feature, if there's a mapping of the data to the visualization itself, whether we're taking data and making it part of the X position or part of the Y position or the shape of the point or the color of the point, we use the AES. And AES is short for aesthetic. So we are mapping the data to the aesthetic, right? If you just want to, across the board, say all the points are blue, or all the points are twice the size that you might normally make them, or what have you, then you don't need to do the AES function.
Okay.
You do ls parentheses package hyphen
In quotes package,
no.
and then
Like hyphen ggplot. Or sorry, colon ggplot.
And then scroll up.
Yeah.
Oh, I got you. I got you. So these are all of the different functions as part of. I see. Okay.
But we want to do that in hexbin, right? I mean, that's what we would have typed in.
Sure.
To figure.
Like that. So these are all the different things in hexbin, for instance. Even that's got a lot, but yeah. So that's a way to do that. Let me jot down that note, and then we're going to return to AES. So list all the functions within. Whoops. Okay. So does that make some sense? When we're mapping data to an aesthetic, we use the aesthetic function, the AES function. When we're just saying all of the points look a particular way, all the lines look a particular way, what have you, then we don't need to use aesthetic. All right, let me jot that down. When we map, and that's kind of a key word too in that visualization world. Data to an aesthetic aesthetic, a visual feature of a plot. We use the AES function if we want to sort of like fix a visual feature of a plot. For instance, all points are blue. We don't need the AES function.
So if we want the opacity to vary by some variable in our data, then we would wrap alpha within AES.
Yep. Exactly right.
Geo point.
Yeah, exactly right. Yeah, and so you can start thinking about all kinds of different ways that you can visualize these data by translating those data to visual features, whether it's the opacity by the population size or something in the Gapminder data set, or like the size of the points based on the population, that sort of thing. So yes, it's exactly right. Mary.
Yeah. So I tried putting color equals species ID in the aesthetic, the first aesthetic, so the before geom point.
Yes.
But like with X, Y, and then I did comma color equals species ID and got the same result, but I imagine that there are probably cases in which, like, I guess I'm just wondering, like, why that position would.
Yep, and that is an excellent thing to head to next. Thank you for the transitions. Let's see, putting the where to put, right? Where to put the AES function call. So let's recreate what we just had. ggplot surveys complete. Sorry. Equals surveys complete. So this is how we had it, right? AES x equals weight, y equals hindfoot length. Geom point. Alpha, right? Alpha equals 0.1, and AES color equals species ID, like that, right? So that's what we had. Version 1. First way we saw it. All right, and are you all okay if I copy this? Okay. Say version 2. You know what? I'm not going to copy it. ggplot data equals survey. I'm going to get really good at typing surveys complete. Surveys complete. Let's leave it there for a second. Oh no, I guess your way you wrapped it up ahead of it, or put AES above it, right? AES x equals weight, y equals length, and color equals species ID. And plus genome. That should return the same thing, right? The idea here is that anything that you put in an aesthetic within the initial ggplot function call gets inherited through the rest of the geometries. So up here, as in this aesthetic that I'm calling a ggplot, I've got x is weight, y is hindfoot length, and color is species ID. That whole aesthetic is also getting put down here into geom point. And if I were to add a geom line, it would get passed down to that. So the default for ggplot is to inherit all of the aesthetics from that initial ggplot function call.
So that could potentially be good if we wanted to like say add, I don't know, like a line for each species, whatever.
Yes, yeah, absolutely. That can either be exactly what you want or really not what you want, right? So it's important to know the distinction there. Yeah, if you want it to be passed through to every single geometry, then yeah, put it at the top, and that saves you from writing it a bunch of times. If you only want that to be part of the points, but then for the lines you don't need the colors by species, then just put it where the geom point goes. Yeah, go ahead.
I was gonna say one thing I like to think about is that if you're using, say, multiple layers, like different data sets even, you wouldn't want to put things in that initial ggplot, because that initial ggplot is like, imagine you're building a house and that's the frame of the house, right? Like everything is going to be built onto that frame. And you can make it look kind of a lot of different ways, but ultimately, like the shape of the frame isn't going to change. If you imagine that you're going to build like a house with an exterior garage and something else, then you would want to take those pieces out and put them in each like geom point, geom line. It's going to have its own scaffolding, basically, its own data, and its own XY, and its own aesthetic. And so it's very flexible, but it's important to know which thing you're after, like what you're trying to do. Like Michael was saying, it's either exactly what you want or very much not what you want. So, but you can do it either way, and you should definitely play around with taking everything out of the ggplot and just stick it in geom point. It does the exact same thing, but when you start adding new layers, that's when it starts becoming very different.
So you could say ggplot, open close parentheses, plus, and then if you had like even different data sets,
I think that's
add them.
I think that's true. Yeah.
As long as they fit in that same axis, like your data has to be plotted on the same XY to some degree. But yeah, you could have different data sets or different data frames that you're using.
Just to be really explicit about this, version 3 here is having just data within the ggplot, and then including all of the aesthetics in geom point. Y equals hind foot length. Color equals species ID. And then outside of the AES, alpha equals 0.1, right? So notice that if I want to keep the same exact plot, the alpha is going to go outside of the aesthetic. So that should result in the same plot. Make sense? Okay, are you all encouraged to come back and learn more ggplot? Okay. We are going to let's call it there. And what I'm going to do is put up the assignments. Which asks you to build some ggplots. We're going to be using that same Gapminder data set. So it's a little bit different from what we've been working with in class. Gives you some practice with a different data set, but it is the same data set that you used for the assignment last week. And on the Google Doc, link to assignment 5 and ENT's team discussion. So that's where the assignments are all going to be going. And if I've done this correctly, if you click on that, week 5 assignment is here. I pinged you all with the @ so hopefully you all get an email if you've got your watch parameter set here and Gmail doesn't shunt it to spam. Yeah, so part 1 asks you to modify some code and write some fresh code based on that modification too. And then we're gonna do the same code review sort of process, right? So there's another tab in that Google Sheet that's randomly assigned you to a new code partner. So yeah, go to their raw file, download it, try to run their code, and file an issue on it with some constructive feedback. So yeah, get in the issue in the habit, I guess, of filing issues. And if you do, you can get a GitHub sticker.
I was gonna say, the folks, I'm gonna go ahead and say some names of folks who can go pick a sticker right now.
Nice. And to tell you what, before you start that, if your name is not called on that Google Sheet also, there's that end of class survey. We could ask you to, again, fill that out. I want to make clear that it's totally anonymous, right? So please let us know how the pace has been. We are here for you, right? So we want to make this class the right pace for all of you, and we've got ways to make that work if you're finding it too slow or too fast. So be honest, and we'll take it all into account. Okay, Ryan, go.
Oh, and I was gonna say, so also FYI, we're just 5 weeks in. So we are halfway through the quarter, which is pretty crazy. And thank you all so far. But we're getting to a point maybe in a week or two where we're gonna actually ask for your feedback on things that you might wanna see. I know I'm back here, sorry. Walk up there. Who's like, I don't know where to look. So not this week necessarily, but maybe next week we might actually send a little poll out to get a sense of, and there's no guarantee we're gonna be able to cover what everybody wants to see, but we're also at a point in the quarter where we can start tweaking things and covering things that you all might be interested in, you know, democratically what gets the most votes, right? Like, do we wanna do something where you learn how to build your own web page? Would that be useful? Do you wanna do something that's like more analysis, ggplotty sort of thing, where it's like a different pipeline where we look at some more advanced analysis with that. Anyway, there's a bunch of examples, and we have some stuff already written up, so we probably throw that up there. I will caveat that with we're probably not going to do a whole bunch of like stats and modeling. That's definitely not. I wouldn't feel comfortable teaching you all of that, and so I want to just make that clear. But we can try to cater to and help people if there's certain things that you might be interested in doing. So keep that in the back of your heads as we go forward in the next few weeks, because by week 7 or 8, we'll have some flexibility, hopefully, towards the end of the quarter with like what we can cover, okay? So yeah, anyway, please fill out the surveys really help us. So thank you. You all have been, the sort of comments have been really helpful in hopefully adjusting this course to what you all want to see. So sweet, all right. And there are stickers, please only take one. There were 2 of each kind, but there's about 30 different kinds up here. So I will just say, if you have filed an issue, I don't want to call names, if you have on your honor, please feel free to come up and grab one sticker. And if you haven't, file an issue this week and come grab one next week. All right. Thanks, all. And I will know.
So good. You're all like, I know. I cover my body. Look at this ninja, guys.